My servers are not mere toys, tools that bring efficiency and poise. They help people make work a breeze and solve logistics with effortless ease. CSPs and logistics, hand in hand, moving data and goods across the land.
Have you ever heard of CSP? In fact, in modern city, CSP is an absolute game changer. It helps with everything from logistics to transport management, mobile network load distribution, hospital staff, standby scheduler, production line optimization, and so much more. In this episode of our Artificial Intelligence course, we are going to explore the world of CSP problems. So, what exactly is Constraint Satisfaction Problem, or CSP? In simple terms, it's a problem that can be solved when each variable has a value that satisfies all the constraints on the variable. It may sound a bit abstract, but it's actually incredibly useful in solving complex real-world problems. To help illustrate this, let's take a look at some examples from the Optiplanner system, a powerful tool used by many companies to optimize their business processes. One such example is vehicle routing problem. This involves finding the best routes for company's fleet of vehicles while optimizing logistic processes. We need to figure out how to optimally select cars with different loads and their routes for customers who order varying quantities of goods, all while using as little fuel and time as possible. The objective of CSP problem in this case is to minimize the total distance traveled by vehicles, while ensuring that each location is visited exactly once. But it gets even more challenging if the customers have specific time intervals when they have to unload and load the goods. By solving this type of problems using CSP, we can make business more efficient. One such application is optimizing the cloud computing server center. This CSP problem is all about efficiently distributing computing processes between servers in a cloud computing center. Each process has its unique requirements, such as memory, CPU, or internet bandwidth. Meanwhile, each server can handle multiple processes within its compute parameters. Plus, each server may come with its own support cost. Luckily, CSP solutions can help us to ensure that the overall cost of maintaining cloud computing is kept to a minimum. This is a huge benefit for companies and organizations that rely heavily on cloud computing services. Another challenge that CSP can help with is scheduling human resources. This is a common issue faced by many large companies, and we can see an example of this in the problem of creating a school scheduler. To create a timetable that meets strict restrictions, such as teacher only being able to teach one class at a time, and loose restrictions such as students not liking gaps between classes, CSP is essential. It's job of CSP to ensure that all activities are planned in a way that maximizes the use of available resources while minimizing conflicts. So why are you relying on cloud computing services or trying to create a school scheduler? CSP is here to help us optimize our resources and achieve our goals more efficiently. CSP search algorithms are powerful tools that use general heuristics to solve complex problems by taking advantage of the state-space structure. The problem of n-queens can become quite challenging using search algorithms that do not take constraints into account, but CSP algorithm can easily find solution for 1000 queens in just a few seconds. One classic example of CSP is the map coloring problem, which aims to color a map so that no two adjacent regions have the same color while using as few colors as possible. A four-color theorem states that any map can be colored with just 4 colors, and this problem remained unsolved for 125 years until it was finally solved in the 1970s. To demonstrate this theorem, we can look at the map of Lithuania and use the GeoPandas library to extract information about neighboring regions and create graphs of these regions. Without CSP algorithms, the resulting map will be multicolored, but with CSP algorithms we can color the counties with 3 colors and the districts with 4. You can find all the code and maps on my GitHub portal, and the links can be found below this video. CSP switch algorithms are fascinating tools that can solve complex problems quickly and efficiently, and the map coloring problem is just one example of their power. Let's dive into another classical problem of CSP, the traveling salesman problem. Imagine a salesman who needs to visit several cities but wants to do so in the shortest possible route, without revisiting any city and returning to the same starting point. This problem is often used to solve other complex problems, such as logistics, bus routes, and drone flight planning. Finding an exact solution becomes nearly impossible as the number of cities increases, but an approximate solution often suffices. The algorithms we see in action here utilizes a temperature parameter to randomly guess solution, with it then consistently optimize it. By lowering the temperature parameter, we stabilize solution to achieve an almost optimal visiting route through 62 Lithuanian cities. This problem can be applied to any other country and used to find the optimal route for visiting multiple cities. As an example, we can use these algorithms to find the best route for visiting the largest cities of Ukraine. Now, let's delve into our workings of one of the simplest algorithms that showcases the principles of CSP siege in the state space. This algorithm consistently attempts to assign values to variables that result in the least number of conflicts. Initially, the algorithm generates a solution and assigns values to variables. Then it randomly selects variables that have conflicts and tries to change their assigned values to a new value with the minimum number of conflicts. Let's look now at another popular CSP algorithm, but this time in debug mode, which allows us better understand how it works. To start, we will open coloring map by program and set a breakpoint on the CSP map coloring CSP line. Then we will start the debug mode and stand on a given line and press F8, which creates a description of coloring problem with the address stored in the variable region CSP. After standing on the next line, we will press F7 and enter the code that implements the algorithm. It's worth noting that the function backtracking siege has an internal function called backtrack, which will be called recursively. We will press F7 on the line where the backtrack function is called and start the search. The next thing we will see is a cycle whose main idea is to take one variable sequentially and then take the possible values of that variable that do not conflict with the already arranged variables. If we found ourselves in that end while searching, we cannot assign a non-conflict value to the certain variable. We will go back to the search tree to a point where a new branch can be tried. To sum up, CSP is a valuable approach that can be applied to solve a wide range of complex problems across various fields. By leveraging the state space structure and general heuristics, CSP can effectively solve challenging problems. The examples we have discussed in this presentation illustrate the practical applications of CSP in real-world scenarios, such as logistics, resource allocation, and education.